Student friends, yesterday we have completed the first topic of paper number 5, namely rectifier, filters and the voltage regulators. We have studied that particular topic in all respects as far as syllabus is being considered, where we have studied. In short, we are revising the same. Rectifiers are the circuits that are used to convert alternating current into pulsating DC. These circuitries are classified basically into two types. One is half-wave rectifier, in which only half of the input AC cycle will be converted into pulsating DC. Means in the output, current flows only for half of the input cycle. We studied the construction of half-wave rectifier, its working, and along with the necessary derivations for DC current IDC, DC voltage VDC, ripple factor, efficiency, and also the peak inverse voltage along with the necessary waveforms. Then you have studied the full wave rectifiers, which are of two types. One is a center type of full wave rectifier and second one is bridge type of full wave rectifier. We studied details regarding the construction and working of center type of full wave rectifier along with the necessary derivations of IDC, VDC, ripple factor, efficiency, and also peak inverse voltage along with the necessary waveforms. After that, we have covered the bridge rectifier along with its construction and working. These are called as full wave rectifiers only because in the output current flows throughout the full of AC input cycle. After completing the rectifiers, we studied the filters. As rectifier circuitry possesses some amount of AC in the output DC, to eliminate that AC, to reduce that amount of AC in the output DC, the filter circuitries are connected in between rectifier and load resistance. We classified the filter circuit into four types. One is inductance filter, second one is capacitor filter, third one is LC filter, fourth one is pi filter. We studied details regarding the capacitor filter because it is the part of your syllabus. After that, we have studied the voltage regulators, where we have defined the voltage regulation is a process by means of which the output voltage is maintained constant irrespective of the variation of load resistance and that of the line voltage. We also defined the voltage regulation factor. It is a ratio of V no load minus V full load upon V full load. Then we studied the designing of Zener diode as a voltage regulator by using the property of the Zener diode that it has a very sharp and distinct breakdown voltage when it is connected in reverse bias condition. And by using that, we designed the voltage regulator for the line as well as the load regulation. So these are the aspects we have covered in the first topic. Friends, we have completed that particular topic. Now today, just we are discussing about the questions which are likely to be asked on that, which are presented in the question bank. as per your university question paper nature, almost all questions likely to be associated with the topic 1 are represented here. So you are requested to answer all these questions, or you have to write the answer of all these questions in your notebook by using the video lectures which are given up till now, till the completion of the topic 1. So the question number 1 is associated. Select the correct alternatives for the following. Just I will read the questions. Answers will be written by yourself. 1. A circuit that converts AC into pulsating DC is dash dash circuit. In half-wave rectifiers, the load current flows dash dash cycle of the input signal. In full-wave rectifier, the load current flows dash dash cycle of the input signal. In full-wave rectifier, the current in each of the diodes flows dash dash cycle of the input signal. The ripple factor of bridge rectifier is dash dash. The ripple factor of half-wave rectifier is dash dash. The ripple factor of full-wave rectifier is dash dash. The efficiency of bridge rectifier is dash dash. The efficiency of half-wave rectifier is dash dash. The efficiency of center tap of full-wave rectifier is dash dash. Bridge rectifier is preferred to center tap rectifier, full-wave rectifier because dash dash. To reduce amount of AC in pulsating DC from the rectifier circuit, dash dash circuit is used. The use of capacitor filter in rectifier circuit gives satisfactory performance only for dash dash current. The peak inverse voltage of half-wave rectifier is dash dash. The peak inverse voltage of center tap rectifier is dash dash. The peak inverse voltage of bridge rectifier is dash dash. The DC current in half-wave rectifier is dash dash. The DC current in full-wave rectifier is dash dash. The formula of ripple factor for half-wave rectifier is dash dash. Dash rectifier uses 4 diodes. The formula of efficiency of full-wave rectifier is dash dash. Dash is a non-essential component of DC power supply. The circuit that maintains the constant DC output voltage in spite of variation of line voltage and load resistance is dash dash circuit. Percentage of voltage regulation of voltage supply for providing 100 volt, unloaded 95 volt. Percentage of voltage regulation of voltage supply for providing 100 volt unloaded and 95 volt full load is dash dash. The main job of voltage regulator is to provide a nearly dash dash voltage. An ideal voltage regulator has a voltage regulation of dash dash. So all these are objective type questions. Friends, you have to write the correct answers for these just by watching the video lectures. In university answer papers, 4 alternatives are provided for each of the objective type questions and you have to select one of them. But here I have not given the alternatives. So you have to write the correct answer. But in examination, for every objective type question, 4 options are given, out of which you have to select the one. So I hope you are following what I want to say. In university examinations, there will be questions of short answer type questions. These will be for 2 marks. As far as objective questions are there, those will be asked for 1 mark question. So I will just read the short answer type questions. Define rectification and rectifier for 2 marks. Give classification of rectifiers. Define ripple factor and give ripple factor for bridge wave rectifier. Define efficiency and give efficiency of half wave rectifier. Here the rectifiers may going to change. In place of bridge, maybe it is a center tap. In place of half wave rectifier, maybe it is bridge or center tap. In case of bridge, it may be half wave rectifier. Those changes may going to occur. Next is define peak inverse voltage. Give its value for center tap of the rectifier. Here also changes may going to happen. It may be replaced by bridge rectifier or it may be replaced by half wave rectifier. So that the number of the short answer type questions may going to increase. Define filter circuit. Give its classification. Define line and load regulation. Define regulation factor and give its formula. Define voltage regulation. Why bridge rectifier is superior than rest of the rectifiers. So these are the 2 marks questions which are likely to be asked. Students are informed to write the answers of these questions in your notebook. Next, there will be questions for 3, 4 and 5 marks. Those will be something like this. What is a rectifier? Give its classification. Explain construction of half wave rectifier. Next, explain construction and working of capacitor filter. Next will be explain construction and working of bridge rectifier. What is a voltage regulator? Explain regulation factor. Define line and load regulation. Explain construction and working of center tap the full wave rectifier. Explain construction and working of half wave rectifier. What is filter? Give its classification. Explain capacitor filter. Compare half wave, center tap the full wave and bridge rectifier with each other. So these are the questions likely to be asked for either for 3 marks, 4 marks or 5 marks in your university question papers. The last type of questions are long answer type questions which will be asked only for 5 marks or more than that. Those are likely to be. Question number 1. Explain construction and working of half wave rectifier and derive its equations for output current, output voltage, ripple factor, efficiency and peak inverse voltage. Maybe changes in the derivation that occurs. These factors may be going to be reduced. Out of so many factors, maybe factors are 2 or 3. That type of changes may possible. Explain construction and working of center tap rectifier and derive its equations for output current, output voltage, ripple factor, efficiency and peak inverse voltage. Here also the number of the factors given for the deriving may be reduced. Next, explain and design Zener diode as a voltage regulator. Next will be explain construction and working of full wave bridge rectifier along with the necessary waveforms. Explain construction and working of full wave center tap rectifier along with the necessary waveforms. Explain construction and working of half wave rectifier along with the necessary waveforms. So these are the questions likely to be associated with the topic number 1. Student friends, you are informed to write the answers of these particular questions in your notebook. I hope you will do this particular exercise. If you have got any queries, any difficulties, regarding writing these particular answers, you may communicate with me on my mobile number, with my email ID, or the WhatsApp group which are for the subject communication purpose, and also with the help of the SPM app formulated to watch the videos. So that's all about the today's lecture. That completes your first topic. Tomorrow onwards we will start with the second topic, namely biasing of transistor or transistor biasing. Friends, if you write the answers for these questions, definitely you will be going to get good marks. These questions are useful for you for acquiring the knowledge and also appearing for the examination. So that's all about today's lecture. We will meet next time with next topic.